what I wanted to show you today is the recent work that we are doing and the date of the last presentation I did over the last events on how we are dealing with 1 petabyte of time series data using autonomous data warehouse. I would say that this is critical data for us. So let's see whether I can move the slides. Okay, so at CERN we have a, sorry, let me just see whether I can get back to, sorry for the mess with the slides, so, okay. It's because there is a little bit on delay and this is a little bit complicated, but now we are on track. Sorry for that. So what I was saying is that at CERN we have to deal with, in order to achieve our mandate, which is understanding how the universe is made of and what is the building blocks of everything. So we have to deal with some of the most complex scientific instruments the human being have ever built. For that, I mean, what you see in the picture is the late C is one of the flagship experiments. But for that, we have a very complicated control system that collect data from the devices connected down in the tunnel and then send it somewhere. In our case today is an Oracle database, and this is the story that I want to tell you today is how we are migrating for this database to the cloud using ADW and the object storage. Okay, so, oops. Voila. So this system is a Xen accelerator logging service. This system, what it does is take all metrics coming from the control system of the accelerator itself, a SCADA system, and then it's sent into a central database. There we store data from the accelerator system, cryogenics, vacuum, matching protection, radiation, etc. But as well for some of the detectors, those big experiments that are colliding particles and taking pictures like Atlas, EMS. Just with you, I mean, what I wanted to say here, that all these small pieces, or even not that small pieces, need to work at a perfect symphony. And for that, it's critical that we manage to control that very well. So just to give you the idea that the database or the data management aspect that we have here is really, really critical for our daily base operations and organization. So today, the system is about 1.1 petabyte of time series data coming from more than 2 million signals. So we are collecting today 2.5 terabytes of data per day. So, and the data is really a heterogeneous one. So we are ranging from simple scalars to a rise of more than 4 million elements. So this data is accessed to more than 1,000 users, and there are more than 100 different expert applications that take decisions whether we have to continue the operations, whether the beams is the correct manner, so on and so forth. So the system that we have at the moment, which is an Oracle database, on-premise database, has some really advantages. It's a very simple architecture. We are using a racks with two nodes. This is really efficient. It's covered 90% of the use cases. Let me see. It's covered 90% of the use cases. And allowed to create, this point is very important. So it allows to control critical system in almost real time. Because, you know, the data is coming and we have to take decisions in almost real time. The current system that we have, it's allowing that. So, but then there is some aspect that we wanted to improve. The first thing is data exploration. So with the current system is very good in these 90% of the use cases, which normally are cases where you know what you're looking for. It's happened to be a small data set and you can retrieve just using SQL, Java APIs on all the interfaces that you're having, yeah? And the second aspect that we are getting a part of these data exploration capacities is getting better performance on bigger data sets, which is somehow related to the previous one. Let me see whether I can move the slides. So, and this is where ADW came into the game. And now what I'm going to tell you in a summary manner, in a very fast manner, why and how we're using ADW to sort out this problem. So why? Because we were looking for finding a better alternative for what we have to get these extra 10% of the use cases that actually, even if the number is small, the criticality is very much, is very big. So we need to continue with a very simple architecture. So we need to facilitate data exploration. We need to control critical system in normal real time. And this is very important because this is one of the things that you have to keep in mind instead of just moving to, if you wanted to if you wanted to keep this kind of systems. I mean, because this is essential. Otherwise, you can try things like Hadoop or whatever, which is something that we did. But at the end of the day, this osmo real-time accessing to the data is something that is really critical for us, and that takes us to continue with the same infrastructure, just moving into the cloud. So another thing is that we need to lower the operations development cost, and this is something that with Autonomous you can get very easily. Reduce migration and integration efforts. At the end of the day, we are using the same system, whether it was on-premise and now EDW. The basics are kind of the same, even if you get, of course, some benefit out of this. And the most important thing, or just the last thing, is transparent and easy access to advanced optimization features. So, when you get into the EDW, all the tricks that you need to do in order to optimize your system are kind of done automatically. And this is really essential because that liberates some of your people to do something else. So for that, what we put in place is that we got the data from the control system. We generate some Parquet files, and then I will get a little bit into details on this. So then we have to transfer the data. We're using 3 different manners that as I said, I will get into that. We put the data in this Parquet file into object storage, and then we are using the big data layer of the ADW to access this data as external tables. And then we put an analytic layer on the top, which is based on Oracle Analytic Cloud. So the data acquisition is just to simplify the thing, is that data is flowing from the control system. We have a staging area, and in the middle there is Kafka. So Kafka is getting the data from the control system, is doing some small transformation that we need to do, is landing in the staging area as a Parquet file. And these Parquet files are the basis that we need to send to the object storage to later on to access to these things. So this is important to mention here as well, that we're using a data schema in the Parquet file that is later on to be used to define the schema on the tables that we keep creating, or the external table that we're creating in ADW. And this is actually done almost automatically, and you don't have much to do on this sense. So then it came to the next point, which is about transferring the data. I mean, we have to transfer more than 1 petabyte of data from our on-premises services disks in our data center to the object storage in the cloud. And this is not an easy task. But I would like to split this into two major things. So the first thing is to move these 2.5 terabytes of data per day. This is something that we need to do continuously. Every single day, 2.5 terabytes are coming, and then we move it to the object storage. And this is very easily, I mean, 2.5 terabytes, we can do that overnight, and this is not a big deal, and we're using the OCI REST APIs to do that. So we have created a little bit of the automatization layer, which scan the staging area, which in our case is the SDFS, and then move this data to the object store overnight, and this is very simple to do. However, moving 1.1 petabytes is not, which is historical data, is not as easy as you can imagine. So the first try that we did, or the first thing that we tried to do, is using this Oracle Data Transfer Appliance, which is machines of 150 terabytes per machine that can be just copied from the local disk in your data center, shipped to Oracle, and then magically it will show up in your object storage. However, we were planning to do that, and then suddenly the COVID came, and then there was access to our institution, data center was almost closed, so we didn't manage to get this done on time before the COVID just arrived. So, and then the next thing is about how do you move still if you don't have these machines. So we're working together to the network in order that it's one of the providers you can get from Oracle, which somehow increased the capabilities to send data. And this is why we're doing these things. This is an ongoing process at the moment, because if you see the figures down, it tells you that it will take a few months to that. In the best scenario, still it's 1.1 petabytes, so it's an enormous amount of data. But I will say that this is on a good track. So answer data is in object store. So Oracle just put in place some DBMS cloud packages that will simplify your life as everything is down autonomous, honestly speaking. So you can use these packages to scan what is in the object store and create tables and partitions based on the files, in our case, on the Parquet files that you have there. And again, we create a little bit of automatization layer that help us to do that automatically, and then we don't have to intervene by ourselves, and everything is done automatically. So then the next question for us is that how we can optimize in order to answer or to give an answer to these almost real-time access things. And then we have two things. So if you use Parquet files and object store in ADW access into that, I mean, this is not a problem anymore. I mean, you have almost real-time access to the data already, because the performance that you get is really, really, really impressive. However, we wanted to go one step further. And then we say, why not to use this capability for ADW to work with hybrid partitions table when you have the hot data really in tables in the ADW storage, and then you access partitions, or you access the high or the external tables for those data that is not accessed so often for this cold data. So we put in place the hybrid system, and actually the performance that we are getting is really, really impressive. And actually that gives us the chance to reply to these requests that's asking us to have almost real-time access to our data, which is critical for our operations, daily-based operations. So, but then this is on top. I said before that we have to put something in top of this to allow our users. In some cases, they don't have the knowledge to explore data because they don't have this, background on data analysis or these kind of things. They just wanted to see how the things are reacting. And then for that, Oracle Analytic Cloud was the kind of solution that we put in place, and that was very successful as well. So previously, the situation that we have for accessing data, custom Java APIs, custom Java applications, notebooks. We put some Jupyter, but that was not moving that fast. But somehow there were some limitations. There were no exploration tools, push lots to clients, because otherwise the database will get into trouble, and requires, which is important, advanced users. Even at CERN, we have problems to find these kind of users. Well, with the Oracle Analytic Cloud, we got a complete set of that cover all our needs. So for one side, we have an exploration tool, which is seamless and easy to use and very straightforward. It's part of the autonomous strategy. So for Oracle autonomous strategy. So you don't have to care that much about this. So it's automatically home creation, administration, patches, backup, everything is done. So you don't have to worry anymore about this. And the most important thing was clicks provisioning and scaling. You can scale up and down as you request, yeah, which allows to solve some cost. So, and this is kind of everything I wanted to say. Just to say thank you once again to Rainy and all of you for being here today.